just to offer a little context and a little quick preface. Really, we start off as wide do the footings of houses have to be below that of the frost line, and what would happen if you didn't do that. As many of us know, water expands when it freezes, and that expansion creates considerable force to create a larger volume for the water to occupy, enough force to heave up a highway section weighing dozens of tons. It's enough force to lift an entire house and to lift it unevenly, cracking the foundation. So when cinder blocks of a foundation are separating them at mortar joints, opening the foundation to groundwater leakage. So this is a cross section of what a footer would look like, a conventional cast in place concrete footer. And when the ground freezes, if the footer is above this indicated frost line right here, it would actually heave and push that foundation footer up. Whereas if it's that cast in place footer with this cast in place concrete wall section here, if this footer is below frost line, then it won't do that heaving. Most building codes in cold climates require foundation footings to be placed below the frost line, which can be up to 4 feet deep in northern United States. And the goal is to protect the foundations from frost heaving, obviously. So when we talk about J-forms, we start to introduce the notion of frost protected shallow footings and why they're used. There's an exception to this standard. Many codes permit foundations to lie above frost line as long as they're protected from frost. However, approval depends on local code officials and may require special engineering. So they do allow for shallow footing systems, and that's where a lot of times gets asked when we're talking about J-forms. In other words, do we have to dig down to frost if we're using J-forms? And that's part of what we're going to be going through here on this presentation here. But remember, this is really important to remember, approval really depends on the local code officials. And that oftentimes whoever you're catering to with the J-forms is going to have to dig into that with the assistance of obviously Build Smart Institute where we can. A frost protected shallow foundation, FPSF, is a practical alternative to deeper, more costly foundations in colder regions. This is important to understand with seasonal ground freezing and the potential for frost heave. Whatever course we go through, and I'm going to outline a few different paths that you can go through with the J-forms. At the end of the day, the builder, the owner can save significant cost, whether they have to dig to frost line or if they can go to a shallow depth by way of the use of the J-forms, and I'll get into detail as to what that means. Houses and other structures may be built on shallow slab-on grade foundations in cold climates when properly insulated to protect against frost heave. In a heated building, the frost-protected shallow foundation relies on heat from the house to raise the soil temperatures around the foundation, and one layer of insulation covers the outside face of the foundation while the second extends horizontally away from it. That's essentially what we see in the conventional wing insulation, and I'll share a detail with that in regards to that here in a minute. The rigid foam traps any heat that the ground absorbs from the building, keeping the soil temperatures around the footing above freezing. So the idea is in this shallow footing, you're actually heating underneath of this shallow footing. The heat from the building is allowed to escape and essentially get slowed down to escape to the colder air. We always have to keep in mind that hot always moves to cold. So as the heat of the building tries to escape, it's going underneath the footer and keeping it warm. In the case of the shallow footing, that's why you can do the shallow footing. You're allowing the heat to escape. Now that's counter to what we're trying to accomplish with the J-form, and I'll build on this from here. So keep in mind that increasing the floor insulation will decrease the heat flow to the foundation, and more perimeter insulation will be required. So in unheated buildings, additional measures are required for an unheated building. Unheated garages and other buildings rely on heat from the earth, which is a fairly constant 50 degrees instead of heat from the buildings. So when we're doing this in an unheated building, a drainage layer is only recommended under wing insulation for heated buildings. A 6-inch drainage layer is required under unheated shallow footing designs. Additionally, the horizontal ground insulation extends not only as a wing beyond the perimeter of the building, but continues under the entire unheated portion of the building. This insulation layer can be installed either directly under the slab or entirely at one level beneath the lowest portion of the footing. So let's demonstrate this now graphically. What they're saying is, if you want to do a shallow footing, so you can see the frost line is below where this gravel footing is right here, this shallow footing. So the frost line's below it. If you're doing this conventionally, this can heave this footing up like we discussed previously. What this shallow footing is relying on is heat loss from the building now comes up and warms up underneath this shallow footing. Therefore, it'll prevent it from heaving. And the way this does it is this box here indicates that wing insulation, which is exterior, outside, outboard of the foundation itself. So the heat from the building gets essentially slowed down. So remember, heat's always moving the cold. So it slows down, essentially keeps the soil warm underneath this footer, this gravel footer, and therefore it won't heave. Now in our J-form assembly and the corresponding slab insulation underneath the slab in the high-performing buildings such as Passive House and with the J-form assembly, it does not allow heat loss from the building. So therefore there has to be a whole nother approach as to whether wing insulation is required or not required in conjunction with the J-forms. So when we look at this, we have to look very directly at these tech notes from Covenant Engineering. I'm going to bring this document up so we can see it in its entirety here. And it goes through about how heaving the frost can heave up the foundations like we just previously discussed. So the time-proven method is to place the foundation structures deep enough below the ground surface so that freezing can't take place beneath them, similar to the practice of placing water pipes deep enough in the ground so water doesn't freeze them. It's also been recognized that in heated buildings, there's heat loss through the floor construction like we just discussed, and to some extent to the foundation material, usually the soil below the structures, and there's also passages of heat from beneath the structure to the ground surface during cold weather. If insulation is placed on the vertical outside face of the foundation structure, the passage of the heat away from the foundations can be minimized, and placement of the horizontal layer of insulation on the soil outside of the foundation structure provides even more attenuation of the heat loss. So in other words, just like we talked about the wing insulation. But there's been some experimentation that allows decreased frost depth to be determined through the ASCE 32-01, and we're going to talk about that here momentarily. And the 3201 provides climactic data, insulated values for insulation materials and various construction materials, and other tabulated data, which allows one to design a foundation structure which can be installed significantly shallower than the conventional recognized frost depth in a given locality. So it provides essentially the two frost protected shallow footing installations, which we can see here on the tech note. The first is to place a non-frost susceptible layer of material between the footing bearing the surface and the frost depth. So you can see right here, there's the building foundation. This is our conventional J-form with the underslab right here. And then what we see here is there's the designed frost depth. So what we're saying here is you can go and dig a gravel footer to frost depth, essentially compact it and level it off, and then place the J-forms right on there, as long as it's free draining gravel. And then you have a drain tile that can help the water exit away and daylight drainage away from the building. So what this is you're still digging down the frost depth and putting the gravel in there, but what you're walking away from is you're not having to cast in place a footer or construct a block or cast in place stem wall in there. So you're eliminating all that labor and all that materials and all that time, because you're just digging down the frost depth and putting gravel footer in there and putting the foundation, the J-form foundation on there. ASCE 32 allows for that as well, and most code officials will accept this. So this is kind of, if you're having an impasse and you're trying to come to a conclusion as to how to best get the J-forms out there, this is one that you can put out there that's most widely accepted. Dig the frost depth, put the free draining gravel and the drain tile in there, and put your J-forms on top of it. And that's it. And most code officials will accept that. Now, alternatively, there's another thing you can do as well. And this gives another frost protection detail right here. You can see they have the stone fill and then the filter fabric and then the drainage to daylight. So it gives you another section as to what we're talking about right here. The second method is to utilize insulation to prevent ground freezing from beneath the wall footings. And this method recognizes that the foundation structure, most commonly a block or concrete foundation wall on a concrete wall footing, is moderately good heat conductor and serves to conduct heat away from the foundation soil below it to surrounding soils, which have become frozen during significantly colder weather, giving rise to possible frost heave. So if this passage of heat away from the foundation soils may be blocked or attenuated, then one can consider a shallow frost depth otherwise. So we can see right here that if you go through the ASCE 32, there's a way you can arrive at the shallow footing. It's a little bit more involved, but we're going to unpack that here in a little bit more detail. So the lowest hanging fruit is you dig down the frost depth, and you put on your J-form, and then there's no wing insulation involved. And that gravel acts the same as it would be as if we were putting some kind of a foundation and a footer system in. Out here, this is the Build Smart high-performing J-form assembly. It does not allow heat loss from the building. So therefore, there has to be a whole nother approach as to whether wing insulation is required or not required. If you're going down the frost depth, you dig down the frost depth, there's the foundation drain, here's your J-form, here's your underslab insulation. So in this scenario, this does not rely on any heat transfer coming out of the building. It's solely reliant on your digging down the foundation depth. And this is the most, again, universally accepted out there with the code officials and whatnot. And also, this is very compatible with what you're going to see in high performing buildings where they're trying to thermally isolate the interior conditioned space from the exterior. That's where the appetite is going to be for that. Now, on the horizontal wing insulation, this allows more readily to do the shallow footer here, which you can see on your detail here. You have your underslab insulation, your J-form. The footer is dug above frost line, but then it relies on this wing insulation, because what they're saying is now you're not getting any real thermal advantage, any heating from the building. So therefore we need to isolate a little further this footer here so it reduces the heaving. Now this is also widely accepted. Depending on the code official and the locality you're working with, it's going to take some hand holding oftentimes and trying to work through the ASE 32. So we've been talking about this ASE 32, and the ASE 32 is pretty lengthy. It's got a lot of jargon in there with regards to how this operates. And what we've done is we essentially, a couple things. So insulation is provided to retard frost penetration below the foundation and to retard heat flow from beneath the foundation, allowing shallower footing depths to be possible with no added risk of frost damage. That's basically what this intent is. So we actually went through the ASE 32. So we went through and we highlighted all the relevant sections that pertain to the shallow footings and the J-forms. We went through and we highlighted all these sections that pertain to what you're trying to accomplish with the J-forms, all through these sections in the ASE 32. We devised a calculator. It's a slab on grade calculator.